Hey guys, hope you're doing fine. My name is Nishant and we are at the final day of June LeetCoding challenge. Let's look at our question. Word search 2. Given a 2D board and a list of words from the dictionary, find all the words in the board. Okay. Each word must be constructed from letters sequentially adjacent cell, where adjacent cells are horizontally or vertically neighboring. The same letter may not be used more than once in a word. Okay, so we are given a list of words and a board of words. We need to find all the strings or the words in our list that appears in our board. Okay, so for this example, the eat and the word oath appear in our board. Eat is here, eat, and also oath is here, oath. So and we need uh, and the same cell or the same character cannot be used once for finding the same word. Okay, so let's look how we can solve this. So we will be going to use the tree data structure or the try data structure and the backtracking algorithm. Okay, so I have already made a video on try data structure. You can find the link in the top right corner of the video. So let's proceed with our question. So here is our input word list and our input board. Okay, so first we need to construct our tree structure. So a tree basically has its root value as null. Okay, so the tree root has a value null. So the first word is oath and oath's first character is oath. So null's child node will be a vector of type tree node, or this tree structure node, and it will have 26 length, since there are 26 lowercase English alphabets. So here it is. So the first word is oath and oath's first letter is O. Okay, or the character is O. So we go to the index O. Index O is 14. So here we are at 14. We create a new node for it, that is this node. So we created this node and inserted the next character A to it, and then we created a new node for this, that is this T. So all these nodes are of length 26. So just for the sake of clarity, I have made them small and they extend up to 26 characters. Okay. Okay, one more thing for the tree structure, that for each node we will also maintain a variable or a boolean value that determines if it's the end of the word or not. Okay, so for the first it will be false, and for this it will be false. For this it is true, since the word ends here, eat. So for this node the value of our variable will be t. Similarly for this it will be false, and for this it will be true. Similarly for this is false and this is true, and now false, and true. Okay, so this will help us determine if the word ends here, or we can still go deep down the tree. Okay, so now for our first character in our board, that is O, we go to the root of the tree and check for in its child node that if the value of O is null or not. Since O is not null, we add O to our answer. Okay, and before proceeding, what we do is we also mark this O as hash. Okay, we mark this O as hash, so that if we when we go in the recursion for this cell, if we encounter it again, we must not use it again. That was the condition. You can use a cell only once for the same word. Okay, since this is done, now the vertical, and we go for the vertical and horizontal neighbors of O, that is A and E, and we also update the root. So now we are at this point, that is this node, which is having value A. Okay, now we check if E is null or not. Since for O, the value of E is null. Okay, so we just return here, and we go to the, now for value A, since A is not null, we add this A to our answer, that is A. And since the value of isNt is false, our word is not yet completed, and we also have to mark this A as hash. And now we update our root value. So we are at this node now, T. Now we go into the recursion for this A to its neighboring adjacent cells, that is A, this cell, and this T. Since this is marked as pound or hash, we simply return this, and we go to the value A. And since A is null here, we don't do nothing. Now for T, we visit the T here and mark it as hash, and also add it to our answer, that is T. And now we move down to this node, and we go in the recursion for this T. Since it's left E is null, we do nothing, and again A is null in this node, we do nothing. We go to H. Since H is not null, we add H to our answer, and this is it. Since the end value for this word is true, since now we formed our word oaths, and we found that in our board, in the given board. Okay, so this is it. We found oath, and we just push it into our answer. Okay, so after we backtrack, we just reset these values to their original uh, character values, that was H, T, A, and O. E is here, so E is not null, we are good. Now we go to A. So its neighboring, we mark it as this, and our neighboring cells have value T and I, which are both null for E. Only A is not null, so this is done, and we just backtrack and we do nothing here. And now we are at T and A, and now E. Okay, so this E is done. So since, and we are at this node now, and we go to its neighboring cells, that is N, R, and A. We do nothing for N and R, since N and R is null for this A, and A is not null. So this E and A is in the answer, and we again go for the recursion for its neighboring cells, that is A, K, T, and this pound. Since this is pound, it will do nothing, and for A and K the values are null, only T has value not null, so T is also done. And we go T, and for value T, our end variable has a value true, and we just add it in our answer. Okay, so this is how this is going to work. Okay, so okay, let's go now, check how we'll code this. So this is it. Now we need to define our tree node class. Tree node, and it will have two values, a vector of this pointer objects children, and let's call our that n variable as end, and now we need to define the constructor for it. Tree node, what we do is we just define our vector of children as size 26 and initialize each value to null. Okay, and also the end value to false. Okay, and again, and one more class we need to define for our tree data structure, and let's just do this public tree node star root. Okay, so we'll have the root value here, and let's define the constructor for this. So this will take our words vector as the argument, and we'll just build the tree here. So we initialize the root, we assign the memory to our root variable through the tree node constructor, and for each word in words we simply insert it into our tree data structure. Now let's define our insert function. So this will take the word as the argument, and first we need to get the index of, okay, so for each character in this word we get the index of that character. So for A the index is 0, for the B index is 2, 1, and for C it's 2, and so on and on. So if the roots children at this index is having value null, okay, let's not use root here, let's use a temporary variable. Okay, so this way we will not update our root value, so we just need to create a new child node for this particular value. So we'll do it like this, and we just update our temp value to this. Okay, and in the end we need to also update the end variable as true, since we inserted the whole word. So the last node should have the end value true, and all the nodes will be initialized to a false value by using this constructor. Okay, so here we are done. Now we need to create, let's use a set so that we don't have duplicates in our answer, and we go from the first cell to the last of our board, that is this plus, and for int j equals to 0, j less than board of 0 dot size, C++, and we will do our recursion here. Okay, and this is it. So, and we need to define this function as well, void dfs. So what parameters will take? So it will take the board value, the current cell's position, and a word in which will we append all the characters, and what one more thing it will take the root of our try, and this should do it. Okay, and our answer variable, that is set string, we'll pass it by reference, let's name it res. So this is it. So any point the position is out of the board, we simply return it board dot size, or j is greater than equal to board of 0 size, and the important one is if the board has a value of pound, this character has a value of pound, we simply return, otherwise we just get this character from the board as it, and we check if this character's index is not null. So this will do the check, that is c minus a, we get the index. If it is not null, we simply add this character to our word, and we go to the child of this particular node, that is c minus a. Okay, and we check if this node's end variable value is true, then what we do is we simply insert our formed word into the answer. Okay, and for now what we do is, since we traverse this cell, we update it to pound so that we do not use it again. We go dfs. Now we have to do for all the 4 adjacent neighbors, that is I plus 1 j, and the word and the root and our answer container. So we'll do it for left, right, left, and up and down. And after we backtrack, we need to reset it to its original value, that is c. We already taken its original value in the variable c, and we just giving it back here. Okay, so this needs we pass the board, the current ij values, initially the word string is empty, the root, and we'll get the root from here. So we need to we initialize our tree data structure, to the constructor we pass this word list to initialize our tree data structure, and for tree node we get the root. So let's define a function to get the root. Let's define another function, get root here, get root. It will just simply return this root variable. So this is it, and we'll call it here using this object of tree class. So that is it, we got the root, and we need to return a vector of strings, not a set. So what we do is we initialize a vector, string vector, let's name it answer, and we push all the elements of this set into this answer. So for auto id in our res, we just answer dot push back it, and we return answer here. Okay, this is it. Let's run this. So there are no errors. Okay, we forgot to pass our set here. So okay, this is good. Let's run now. And eat out, and let's just submit this. Okay guys, this is accepted. The link for the code is in the description. Thanks for watching. See you next time.